Bismillahirrahmanirrahim. Hello everyone. Today we are going to discuss about the structures uh, from the equilibrium point of view. Structures from the equilibrium point of view can be categorized as statically determinate structures, and they can be categorized also as statically indeterminate structures. Okay. So let's see what are statically determinate structures. Statically determinate structures are for those bodies which are supported by the minimum number of constraints necessary to ensure an equilibrium configurations are called statically determinate, and for such bodies the equilibrium equations are sufficient to determine the unknown external forces. Okay, so what does it means? It means that all those statically determinate structures, the number of unknowns in that structure will always be equal to the number of equilibrium equations that are always there for a structure in two dimensions. Okay, so this is a very precise definition of statically determinate structures. Okay, and you can always find out and by seeing a structure by this equation. If you see that the number of unknowns by the means of supports the structure which are supporting the structure, if those unknowns if those unknowns are equal to the equations of equilibrium, you will always say that structure is a statically determinate structure. Okay, if you look at this beam, okay, you can see there is a pin support here. This is a pin support, and there is a roller support. If you look at it, a pin support will always gives you two reactions. Okay, it will always gives you two reactions, and a roller support, will always give you one reaction. So if you add all those three reactions, unknown reactions, 1, 2, 3. So pin and roller are giving you three unknown reactions. And in 2D, you will always have how many equations of equilibrium? Three equations of equilibrium. And you already know what are those three equations. They are sigma fx equal to 0, sigma fy equal to 0, and summation of all the moments about any point about A or B will be equal to 0. Okay, those are the equations of equilibrium. Okay, if you look at another cantilever beam, okay, this cantilever beam, if you look at it, is fixed. A fixed support will always give you three reactions. One, two, a reaction basically are force reactions, and this is the moment. Okay, and moment is at A, so it is ma. So there are three unknown reactions, and again, the equations of equilibrium in 2D will always be equal to 3. And what are those three equations? Sigma fx equal to 0, sigma fy equal to 0, and sigma ma equal to 0. From sigma fx, you can find this reaction. From sigma fy, you can find this vertical reaction. And by using sigma ma, you're going to find the unknown moments. So these are statically determinate structures and their practical examples from the real world life. Now see, what are statically indeterminate structures? A rigid body, a rigid combination of elements treated as a single body which possesses more external supports or constraints than are necessary to maintain an equilibrium position is called statically indeterminate. Okay, so what does it means? That it has more number of supports or more number of reactions than the equations of equilibrium. This is what do you mean by are statically indeterminate structures, that the number of unknowns provided by the constraints or supports will always be greater than the number of equations of equilibrium. Okay, so if you look at this beam, you will see that there are one roller here, one roller here. So it means it will give you one reaction of the roller Cy, another reaction of the roller here. Two unknowns, and there is a fixed support. This fixed support, as you already know, will always give you three reactions. Okay, Ax, Ay, and this moment, Ma. Okay, this is an external moment, 2 kilonewton. This is not a reaction. This is an external moment, external moment, just like an external force. but this AX, AY and MA are the three unknown reactions. So again here you will have three equations of equilibrium which are mentioned, AX, AY and MA, and you will see there are 3 plus 2, 5 unknowns, 3 equations of equilibrium. So this is according to the above definition. Okay, this is a perfect example of a statically indeterminate structure. If you look at this frame over here, there is a load over here. If you look at it, it's fixed here and fixed here. So if you look, a fixed support will give you 3 reactions, 1, 2, 3. This fixed support will give you 3 reactions, 1, 2, 3. 3 plus 3 is 6 unknowns. And in 2D, how many equations of equilibrium you have? 3 equations of equilibrium. So again, what does it mean? It means that this is a statically indeterminate frame or a structure, whatever you want to say. Okay. You can also have statically indeterminate trusses also, but the basic concept is exactly the same what I have explained to you. Okay. And on the contrary, if you have basically a structure in which you have less unknowns and more equations of equilibrium, it will also be treated as an indeterminate structure, and it will be said to be that the structure is said to be redundant. Okay, that structure will also not be solved. Okay, so this is a very brief and precise definition along with some practical examples of statically indeterminate structures. Hope you would have understood this topic, and I shall come with new topics related to statics and other engineering systems. And I thank you all. Have a good day. And before leaving, I request you all to subscribe to my channel so that you'll be able to see all those challenging engineering related videos that will be helpful for your future and your future understanding. Thanks a lot. Have a good day.